episode. I have been trying to focus on this channel having just short, highly edited, kind of really tight videos, but there's times where it takes me a long time to get the content in order to have those type of like really high quality short videos. So what I've decided is to kind of periodically do these more ad hoc live videos talking about what I'm doing in a more informal way. And this will help bridge the gap with what I'm doing. And it'll help because a lot of times I need to get some feedback from people, like I'm going to do for this episode. And it'll be great to just do things on a more regular basis because I am constantly throughout the week having various things I'm working on that I'm trying to share, and this will help to do things on a more regular basis. So that sometimes it'll be these more ad hoc videos, sometimes it'll be the kind of shorter, um, more edited, like specific is on a particular topic. So for today, we're going to go over a presentation that I'm putting together for web developers. And what I'd like to do is kind of this won't be the sort of final version of this. This is something that I'm just kind of brainstorming, and so this is going to be kind of going over my kind of initial brainstorm of this topic of AI, running AI within web browsers within your web app, and specifically geared content geared towards web developers, in particular people who have a web developer background, not necessarily a machine learning AI background, even though most developers these days um, have experience. Most web developers have had some experience with different AI models and that type of thing. But this really will dive deep into some stuff that I think most people aren't looking at yet, but I think will be popular in the near future. So let me share my presentation. Let's see here. Share and okay. Just make sure that that's working. Okay, great. So, yeah, I mean, there's a lot of different topics in AI, but in different people coming from different backgrounds, all the content, the one unifying theme for everything here, and there's a lot that I'm going to talk about, is for web developers in particular, that their main focus is on web development. But obviously, there's so many new tools and new things coming out related to using machine learning models in different ways. So I want to get into how web developers specifically can leverage that in a way. So there's kind of four categories of stuff, and each of these categories is a huge presentation in itself. So when I actually deliver this, it's definitely going to be delivered in a more um, one piece at a time. I'm probably not going to do all of these all in one sitting unless I'm doing like an all day seminar or something like that. So the first is running AI in your web app. So this is not what most people are doing now, calling out to an API where a machine learning model is running behind some other third party service. Or even if you're running in your own infrastructure, you're likely calling out to it running on the server. This is actually the pre-trained model running inside your web app in the browser. So we're going to talk about that. Training AI in your web app. So similarly, not training it on the server, which is what happens more often. So it happens less often, but there are some good reasons why you may want to and need to and want to. I said that twice. Sorry about that. But you might want to train your AI inside your web app. And then sort of taking it from a different angle when it comes to training, and this is in some ways a very, very different topic, but again, the unifying theme is that it's something that I think web developers are interested in, is the topic of all the different AIs out there training on publicly available web content. This is like there's a lot of sort of ethical discussions here. There's a lot of like, okay, how things work now, how they'll work in the future. Like I have a lot of things to talk about in this category. And then finally, UI UX for AI in your web app. So this would include stuff like how to do things unobtrusively, so that, because these are big models that take a long time to load sometimes, how do you may have a performant app that has a good user experience while you're using these in the browser, and how do you mix and match doing both some um, of your machine learning models in your browser and some back on the server. So there'll be a lot of different patterns that I talk here to have the best possible UI UX for your web apps. All right. Most of what I'm going to talk about today and kind of going over this and brainstorming is in the first category of stuff, running AI in your web app. I'll briefly touch on the other areas, but most of what I'm going to talk about is for this first category. And so when you take a look at you know, everybody has a different architecture when it comes to their application, both for their front end and back end. But this is a sort of normal, standardish, Angular app. You have on the left side the actual client side Angular app running in your browser. You might be getting some resources from, in my case, I use Cloudflare a lot for my edge static assets and compute for web Cloudflare workers, and maybe some other stuff on the edge you might be doing. But then you typically have your backend server cloud services on Google Cloud or AWS or whatever else, and then you may also call directly out to some third-party APIs as well. So most people today, when they're talking about calling out to utilize AI models, they're talking about utilizing it in the back end. So that means calling out to an API somewhere, either for your that you're running inside your Google Cloud, your cloud services, or you're calling it to a third-party API, the OpenAI API, or you could be running models at the edge too. Cloudflare has AI stuff. So there's a lot of different backend options where you're calling out to AI. And we're not necessarily going to talk about those as much in this section. Really, what we're focusing on is in the browser itself. And there's sort of two somewhat flavors here, or there's really three that I'm going to talk about. The first one is the Chrome built-in AI. And so this is a new thing that isn't available to the general public yet. I'm going to talk about a little bit how you can access it and what it's going to look like. But these are some pre-built models that could be built into Chrome itself in the near future. And then you can also download a model into the browser and run it in the browser using some different libraries. So there's different ones you could use, but the two ones that I'm going to focus on are TensorFlow or TensorFlow.js or Transformers.js from Hugging Face. And in both of these cases, you're using these higher level APIs, but you're ultimately downloading a model from some other location into the browser and then running it. So why do you want to do this? Let's talk about disadvantages and advantages of running an AI model in the browser as opposed to calling out an API, and accessing it on the server side. So the disadvantages first is, chief among them is device support right now, because it is something that a lot of times does require certain capabilities on the device that not all devices have. You don't a lot of these actually aren't hard requirements, but they're practical requirements, because if you don't have something like either WebGP or WebGL enabled or capable in the device that's running this, it's going to be super, super slow. Some of the models require WebAssembly, not all of them. Uh, and the ones that do are usually because they're optimized to run faster. Um, you don't necessarily need web workers, but might something that hopefully I'll show in demo code when I get to that is that it's a good idea to have like long running execution. If a model is being executed kind of continuously, it might eat up a lot of your processing and or memory. And it's great if you could run a web worker off the main thread so it doesn't change the user experience at all for the main thread interacting with the web page. And you have to have a certain amount of memory. So, you know, older devices that aren't as high powered, it's just not going to be practical to try to do this. But you can check to make sure the device that you're running your JavaScript code, your client side JavaScript code on, make sure that it has these different capabilities before you start trying to download a huge model and run it. So device support, one disadvantage. Yeah, this generalization concept. So when you are using the OpenAI interface, either you as a user or calling out to the AI API, you are using a generalized model. That means it's usually very big. It can do a lot of different things. It's a general purpose model. And those models, for the most part, it's again impractical, not impossible, but really, for all intents and purposes, impractical to try to run that on the client side in your browser. What is possible is running some of these more narrow AI, something that's more specific, like a very specific objective that you're trying to achieve. The more narrow you can get, the smaller the model, the faster it can run locally. So again, disadvantage that you can't run these more general models. You have to be more narrow, more specific. And then even when you do have a specific model, it's still fairly large. So the initial load performance is going to be slow a lot of times. Even for the really specific models, it typically, from my experience with a lot of the ones that I'm going to demonstrate, it takes like 5 seconds or maybe more to do that initial load. So that's something you have to kind of bake into your how you do things. And I'll have some ideas for kind of UI UX with this part later on, but it's just something you have to be aware of. All right, let's talk about advantages. So even though the initial load performance is slow when you're downloading the model, a lot of times the inference means when you're actually running the model for a set of inputs and just trying to use the pre-trained model to get a prediction, it can be faster than trying to call it to the backend, because you don't have to deal with network latency or anything like that. It's local. It's something that should be very fast to run, and it's a smaller model once it's all loaded into memory. And assuming that you're using some of the different web GPU or WebGL, then not always, but a lot of times you can set it up so that the inference performance is actually very good and potentially even better than trying to run in the back end for some use cases. For sure, cost savings is a big thing, because you can, if you're, especially in the cases where you're running an AI model a lot, if you're doing it all in the back end, especially if you're using a third party API, like if you're running everything through OpenAI's API, like, I mean, it's a not crazy expensive service, but it adds up like a lot of things. And if you're servicing, trying to call it thousands and thousands of times a day, it's definitely going to start to rack up the costs. If you can defer some of that to running it on the client side, it can save some significant money. Like for transcriptions, one of the things that I'm going to show when I get to my code demo, it literally is going to save us thousands of dollars a month for stuff that like we're doing today in production. So it's significant. Scalability, yeah. I mean, you're distributing the load. You're not trying to run all of the load for this model on the back end. Individual users' devices are running the processing for these predictions, so you can ultimately be more scalable. And then offline capable, yeah. I mean, if you want to, I mean, it depends on your use case whether this matters to function even if you don't have a network connection. And then data privacy, again, depends on the use case, but if you want to make sure that a user's data is not being shared, and you don't have to worry about if you're sending a bunch of private data to a third party service and then that third party service is going to ultimately train on your data and include it somewhere else by mistake or whatever in a result, in LLM results for somebody else's query. They do protect, most of the third party providers do try to protect against that. But regardless, when you keep everything locally on the user's machine, it just ultimately is potentially much more secure. But this is a very simple diagram of how uh, things are set up on the client side. It really is much more complicated with a lot of things involved. Going from the lower hardware level of what actual hardware you're running these computations on, which can be pretty intensive. By default, your CPU, your normal basic on your normal device, laptop or whatever, your CPU is being utilized when your web app is running in your browser, but you want to actually get the browser to leverage some of the like more highly powered hardware on your device. So you usually have a graphics card, and if you through WebGPU in the browser, it can get the processing of your model to run in the GPU on your hardware level. But I'm not going to really get into a lot of all these different layers because it can get pretty complicated. I'm still learning a lot of stuff at the lower levels. Really, as web developers, the thing we mostly care about is the higher level API, what our web app is actually interacting with, plus the pre-trained model. So in a different section later on, I'll talk about if you want to create a model from scratch and train it and everything like that. But really, the easier thing is to just grab one of these pre-trained models, use one of these higher level APIs, and call it a day. And you can go pretty darn far just with that. So that's what I'm going to talk about next, is get into each of these three areas: the Chrome built-in AI API, TensorFlow, and then the Hugging Face Transformers.js. So for the Chrome built-in AI, this is something that is only with Chrome Canary, or I think with the latest versions of Chrome, you can do it as well behind an experimental flag. And they try to set it up so that a lot of it is baked into the browser itself, so you don't have to have your code. It's very easy from your in your custom code side to work with these different pre-trained models. So there's 6 pre-trained models that are possible, although the prompt API, which is more like what people are used to with default OpenAI kind of prompt interface is a more generalized model, and it's much bigger. And so the very initial stages of when they were having people try this out in beta and experimental, I think it was available for web apps, but as far as I could tell, it isn't anymore, and it's only available for Chrome extensions because it's easier to package, the bigger model. So really, for web apps, it's just these first five. You're translating text from one language to another. Language detector, detecting what language a certain text is. Summarizing, just saying, like, giving it a block of text and saying, just summarize this for me. The writer one is, write me a email or write me a paragraph that fits this criteria, blah, 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 and it'll write that out. And then the rewriter is, look at this thing that I've written and just rewrite it so that it fits X, Y, and Z, whatever criteria you want. So this is all stuff. So these five different things, in technically, the more generalized models handle all of these, but this is where I'm saying, like, you need to use a more specific model when you are trying to run it inside the browser. And so let's go through an example of what you need to do in order to utilize one of these pre-trained models for the Chrome built-in AI. So the first thing is enabling the Chrome flag. In the future, in theory, you won't have to do this once it's fully in production, available to everybody. But for now, you have to go to your Chrome flags. And so I have one that you can copy and paste into your browser here. But if you just go to Chrome //flags and look through it, you could see all of the different 5 Chrome built-in AI API flags there, and you can enable, disable all of them. And then in your code, once you enable this and then restart your browser, you should have right on your window at the global level for your web app, you should have access to the AI object, which will have all the different models or the APIs rather initially. And so the first thing you can do is just validate that it is capable of running this model. So when you run this, you'll get some information back to see whether it is you have enabled it correctly, whether the model has been downloaded yet, etc. And then once it's capable of running the model, you have to download the model. So the actual model itself, which includes all the different weights and everything like that, is not in your browser yet. So you have to, once you call this create for the first time, it will download it and then you can use it. So again, just 5 seconds, maybe a little bit more depending on your network speed and everything else. And then you just use it. And so this part, the number 4 code runs, even though it is an async operation, it runs really quickly. It's hundreds of milliseconds, if that. It will not be an issue performance-wise to run this, and it'll be very fast. It's the number 3 part that is the slower part that you have to be aware of. And so basically, all the different 5, going back to this, all these different top 5 APIs, slightly different syntax, but it's mostly you just go through these steps and then you can utilize them. So pretty straightforward. All right, for TensorFlow, there are a bunch of pre-trained models, 14 that are for TensorFlow JS. There are more than this that in the community that people have built that you can find out there, but these are the ones that are the best documented and by far the easiest to use. Like every one of these 14 is super, super duper easy to use that I'll go over here an example. They have plenty of example code. All of them are kept up to date. All of them work really well. I didn't, you know, this was much easier than the TensorFlow JS that I'll mention in a second. Although this has a very much smaller number of models that potentially you can utilize. But if one of these fits what you're looking for to accomplish, then definitely check this out. And so the first thing is importing libraries. You have your overall TensorFlow library, but also there is, they actually published NPM libraries for each of the models as well. You import this. This is a fairly big library, but it doesn't actually have the model itself. The actual weights and everything like that are not part of this. Um, so you do that in another step later. So the first, actually, before you download the model, you have to set the TensorFlow backend, which backend I put in quotes because that doesn't mean what for web developers we think of the backend, on server. It is talking about at the hardware level what is going to be running your model. And so for TensorFlow, WebGL is the faster one. Actually, I got to look into. I didn't see WebGPU as an option, and WebGPU is supposed to be the successor to WebGL. So I know the whole history there. I'm gonna have to look into that. But once you set that, then you can download the model. This, again, the slow part. So the syntax for this is slightly different depending on the model. So that's where you got to look at the example code. But this can take 5 seconds or so or whatever, and then use the model. So in this case, I'm doing the speech commands model. So it actually has a very convenient API that will do all the stuff beneath the scenes of getting permission to the user's microphone, listening to it, getting the audio snippets, turning them into a spectrograph, and then analyzing the spectrograph. So like underneath the scenes, this is actually doing a lot of work. And you don't have to use this is the highest level for this particular model, the speech commands one. This is sort of the highest level list API. Most of the libraries that they have, those 14 different pre-trained models, the libraries for them, they allow you to do things at different levels. So if I wanted to, if I had an audio stream from something else that I was already capturing, you can use one of the lower level functions within this library, within the TensorFlow model speech commands library, to send in the spectrograph directly. So there's different ways you can use it, but again, like I said, this is one thing where the documentation is really good, and it should be pretty easy to figure out how to use any of this stuff. All right, for transformers, I didn't put all of my slides together for this. This is where I've gotten to the part where I've filled out most of the slides. So I'm just going to talk a little bit about what I will put in this section. So for transformers, I guess part of it is I want to play around with making it easier for web developers going to Hugging Face for the first time, because at least when I found not necessarily an easy way of narrowing in on the specific model they want. It's like gonna work because, so yes, you can search through the different categories. You can do the free text search to try to find what you need. But the thing I kept running into when I was been trying this out is that I will say, oh, okay, I need speech recognition, and then it'll point me to the most popular. You actually, let's do this. Let's share. Yeah, because you can have it here, and you could sort it by the most likes or whatever else. But the thing is that um, when trying to get it to run in the browser, a lot of these don't necessarily work that well in the browser. So even if it you do narrow it down by transformers.js. So let's see here, libraries and transformers.js. So these in theory should be the ones that work on the client side. Um, and let's see, full text search. Yeah, it's just I mean maybe other people that are more experienced with using a lot of these models may already know like a much easier way, but just like as me as a somewhat, again, coming from web developer background and trying to like find the right one in here, I don't find this interface as easy as simplified, because ultimately there's a lot of Hugging Face has models for all different use cases, and um, I need ones that fit. Well, I guess the biggest thing is making sure that they will run inside my Angular app without any issues. And so what I've had to do before is try to run one, run into some issues, then kind of keep searching around till I find the right one, and actually switch over to, yeah. And so I ended up, yeah, finding this one working the best for the use case was doing speech recognition, like I mentioned. But I tried a couple different ones out before I got into this one to make it work. And I still am trying to think through, and would definitely appreciate suggestions any of you guys might have for the approach of how, like, as a web developer, I know what I'm trying to accomplish. How do I get from where I want to accomplish to find the specific model that will work for in the browser for the constraints that I have in the easiest way without kind of trial and error. And maybe it might be first checking to see if it's in one of the Onyx community ones. Um, I don't know. Any ideas you might have would be appreciated. So I, at some point, and probably not. So the presentation, I probably won't do like get into live coding while I'm doing that. The sort of coding is sort of to help me sort things out, and then I'm going to take pieces of this and put it into the presentation just to make things easier. But this one, I wasn't able to use the kind of pipeline functionality within the Hugging Face Transformers library, which is a higher level API, higher level function, which makes things a lot easier. So I had to use some of the more specific ones. And in my last live video, I did go through this code, so I'm not going to do that again. Let me stop and just go quickly back. Almost done here. I'm just going to wrap things up. Yeah, so was blank now. But I'm gonna figure out, and this is like on my to-do list where I'm at right now, is figuring out the best way. I have it working myself, but I want to kind of give developers, web developers, who aren't familiar, who like their only familiarity with AI is calling out to an API for some third-party service. So for running it actually locally using one of these models from Hugging Face, Um, I have to think through like a guide of how to make that process easier, and then put some code there for it. And that'll be it for the section of like kind of running AI in your web browser and your web app. For training, I think for the training section, I'm going to focus mostly on using TensorFlow just because it seemed like the easiest way to do it. If anybody has any thoughts on other libraries out there that should kind of look at, but I'm basically mostly going to be, it's going to be almost like a TensorFlow tutorial, TensorFlow JS tutorial, and I'll get into the reasons, why you want to train in your web, both, for distributed compute, but also there's a lot of stuff that you can have some kind of self-learning stuff within, for specific users, if you, in theory, depending on what you're trying to accomplish, um, but it can be one of those things where individual users of your web app are able to start customizing your app using their own kind of preferences based off of their behaviors. So I'm gonna come up with some kind of interesting use case along those lines, and go through creating the TensorFlow model from scratch, and then training AI and web content. So like a lot of stuff for this section, uh, so I have a ton of SEO experience. Uh, that's been my main thing for the past couple years, for a while, and I see just like a lot of things right now that's in the process of, so there's stuff of like, okay, should you care about now what you make public versus not, knowing that all these different AI bots are going to be training on your content, um, and then on the flip side, if you are building an AI bot that needs to train up content, what are some easier ways to do this? So actually, one thing I'm going to mention, I did um, start to check out this Exa.ai. Exa, I don't know how I'm saying it, but they're actually building a service specifically for AIs to make it easier for them to search through and train on the web, because it's one thing if you're Google, if you are, from scratch trying to kind of build a web crawler, it's still a ton of pains that you might have to go through or whatever. So there's a lot easier ways to do that now, especially when you're not just trying to crawl the entire web, and you're trying to do something a little bit more focused. So a couple different aspects of this that'll be interesting, I think, for web developers. And then finally, in this section, UI UX, really getting into how the web apps of tomorrow should be built, like kind of the best practices. And there's just like a ton of little things here, both for performance, for you know um, how to uh, do things to make your app smarter without it becoming kind of like a burden on your users, like to maintain like a really high quality user experience and keep things snappy, but then allow for um, these more sophisticated processing potentially to happen in your browser. Get all the benefits without the negative side effects is going to be the biggest theme for this section. All right, and yeah, that's pretty much it. I appreciate any feedback or thoughts you guys may have. You can put it in the comments for this video, or reach out to me on X or Blue Sky, any of the different socials, and let me know what you think. All right. Yeah, from here, once I wrap this up, I am going to get the more edited versions of this stuff out. I might do a few more of these unedited version or more ad hoc ones as I'm trying to like sort through some of the different sections. So yeah, let me know what you think about that as well. Thanks for joining me, and I'll see you guys again next time.